Hey everyone, welcome back to the College Algebra playlist. In this video, I want to talk about something called the Cartesian coordinate system, which is essentially a system we can use to describe locations and changes in location. Alright, so we're going to take a look at some pictures in this video, which is nice because we haven't seen any pictures in a while. We've just been doing a lot of raw algebra. So without further ado, let's just dive right into it. Okay, here we go. The Cartesian coordinate system. This is what the coordinate system looks like, right? It's made up of two axes, right, called the x-axis and the y-axis. All right? So we can use these numbers, right? We can use these quantities to describe locations. All right? One thing I want you to notice about this is that these axes divide the plane up into four pieces, right? These pieces are called quadrants, okay? It moves counterclockwise. Right, so we start here with quadrant 1, we move to the left, we're in quadrant 2, down here we're in quadrant 3, and then over here we're in quadrant 4. All right, we need to know these naming conventions for future college algebra problems. All right, sometimes they'll ask you which quadrant you're in. All right, so that's how that works. And we also want to point out something I call the origin. Right, this is the origin. It's the point 0, 0. All right, everything in the Cartesian coordinate system is measured relative to the origin. Okay? So let's actually jot that down and talk about some definitions here. All right, each point in the coordinate system is identified by its x-coordinate, which is the horizontal displacement from the origin, and its y-coordinate, which is the vertical displacement from the origin. Okay? Together, we write these coordinates as something called an ordered pair. All right? Indicating the combined distance from the origin in the form x comma y. Okay? So everything is measured relative to the origin, and we can use these things called ordered pairs to describe a location. Okay? Here we're asked to plot the points -2, 4, 5, 2, 0, -3, and -4, 0. All right? So let's take these one at a time. The first point, -2, 4, is over here in quadrant 2, right? We move 2 units to the left, right? Left is the negative direction in the x direction, all right? And then we move up by 4, right? Up is the positive direction in the y direction. All right, so that's our first point in black here. Our second point in blue is in quadrant 1, right? We move 5 units to the right and 2 units up, right, to get 5, 2. All right. Our third point is down here on the y-axis. All right, so we're moving 0 units to the right or left, and we go down by 3 units to get 0, -3. All right. And lastly, we have our point in green here, right? -4, 0. We move 4 units to the left, and we don't move up or down. All right. So those are 4 points that we can plot to describe locations. All right. Next, let's talk about equations, right? We can graph an equation by plotting points. Okay. But what does that even mean? What does it mean to graph an equation? Well, when an equation contains both an x variable and a y variable, it's called an equation in 2 variables. And its graph is called a graph in 2 variables. All right, any graph on a 2-dimensional plane is a graph in 2 variables. All right, so that includes the graph of lines, circles, ellipses, hyperbolas, and so on and so forth. All right. So an equation has a related graph, right? We can graph points and then connect those points to show a visual representation of an equation, which is pretty cool. All right. So here we're asked to graph the equation y equals 2x minus 1. All right. To do that, one thing we can do is just plot a bunch of points, right? And then connect the dots to form a picture, all right? So let's just try out some x values to plug in here and see what comes out for y, all right? If we plug in x equals -2, right? We plug that into this equation, we get 2 times -2 minus 1, all right? So y equals -4 minus 1, which is -5, okay? So we take that number, -2, and this number, -5, and put them together in an ordered pair. All right, so that's our first point. If we plug in x equals -1, we'll get y equals -3. All right, so we have -1 comma -3. If we plug in x equals 0, we'll get y equals -1. Okay, so this is another point. If we plug in x equals 1, we get y equals 1. All right, so we have 1, 1. And we can do this as many times as we want. I'm choosing to do it just 5 times here, right? If I plug in x equals 2 for my last value, I get y equals 3. Okay, so I have 2 comma 3. All right, I have 5 points. Now I want to plot these and see what kind of picture shows up. All right, here are my 5 points. Okay, and when we connect the dots, we can see that we get a line. All right, so the equation y equals 2x minus 1 is the equation of a line. All right, one thing that's interesting about this line is that every point on the line satisfies the equation. Okay, in math, when we say something satisfies the equation, we mean it makes it true. Okay, so this x value and this y value, we plug it into the equation, we'll end up with a true equation. All right, it satisfies the equation, so it makes it true. All right, let's try that with an arbitrary point. Okay, let's take this red point here, 3 comma 5, and plug in the values into the equation, and then we'll see if we get something true. Okay, so we'll plug in 3 for x and 5 for y. Okay, so the question is, does 5 equal this? 2 times 3 minus 1. The answer is yes, because on the right hand side we just have 6 minus 1, and 6 minus 1 is 5. So we get a true equation, 5 equals 5. All right. Next, let's talk about the intercepts. Okay. The intercepts of a graph are points at which the graph crosses the axes. The x-intercept is the point at which the graph crosses the x-axis. At this point, the y value is 0. Okay, it has a height of 0 because it's on the x-axis. All right, and similarly, the y-intercept is the point at which the graph crosses the y-axis. All right, at this point, the x value is 0. Right, it hasn't moved to the right or left by any amount because it's on the y-axis. Okay. These definitions are a little confusing in paragraph form. All right, so let's look at this in graphical form. All right, here I have some line. All right, I don't know what its equation is. I'm just looking at its intercepts. All right, I'm interested in where it crosses the y-axis and where it crosses the x-axis. Okay. So this blue point here, right, this is the y-intercept. Right, this is where it crosses the y-axis. And this ordered pair, right, I know it's going to be 0 comma something, right? I've moved 0 units to the right or left, right? So my x value is 0. And this is what I have for my y-intercept, okay? Here, the red point is the x-intercept because this is where the line crosses the x-axis, okay? So for this point, I know that it's something comma 0, right? I know that its y value is 0 because it has a height of 0, right? It hasn't moved up or down by any amount. Okay, so how do we find these question marks, right? How do we find those values? Let's talk about that right now. Okay, here I'm asked to find the intercepts of the equation y equals -2x plus 4. Okay. To find the x-intercept, we can set y equal to 0 and then solve for x. Okay? So let's do that. If we plug in y equals 0 in red here, right, we get 0 equals negative 2x plus 4. Okay? And next we can isolate the x on the right-hand side. All right, usually we isolate on the left-hand side, but we'll change it up this time. All right, no problem. To isolate this x, right, the first thing we need to do is subtract 4 from both sides of the equation. And we get negative 4 equals negative 2x. Okay? And then we need to divide both sides by negative 2. Okay? And we get x equals positive 2. All right? So we have x equals 2 and y equals 0. 2 comma 0. Right? That is the x-intercept, right? That is the point where the graph crosses the x-axis. Okay? Here, we can go through a similar process to find the y-intercept, right? We're going to set x equal to 0 and then solve for y, all right? So let's plug a 0 in here for x, all right? And we'll get y equals negative 2 times 0 plus 4, okay? Negative 2 times 0 is just 0, so we have y equals 0 plus 4, so we have y equals 4, all right? The y is already isolated for us on the left-hand side, so that's pretty nice. All right, we have x equals 0 and y equals 4. All right, so we have a coordinate point 0 comma 4. All right. These are our 2 points, right? It turns out that we only need 2 points to draw a line, all right? So these are the points that we found. We can label them as the y-intercept and the x-intercept, and we can draw our picture, right? And we see that the equation y equals negative 2x plus 4 is another equation for another line. All right? In future videos, we'll talk more about linear equations, all right? And in the next video, we'll talk about something called the distance formula. All right, you can use that to find the distance between 2 points. And we'll also talk about the midpoint formula. You can use that to find the midpoint of a line segment or the center of a circle. All right, so I'll see you in that video. Thank you for watching, and like and subscribe.